Marking and Layout Tools. Section 1. At the end of this section, you should be able to discuss different types of marking and layout tools. A variety of hand tools may be used to produce woodworking projects. It is absolutely important that every woodwork student and woodworker be able to identify woodworking hand tools. Outline their intended use and use them safely. Woodworking tools are usually identified and classified based on their uses. This video will look at common woodworking hand tools used for making and layout of most common joints used in the construction of furniture and woodworks. Marking and layout tools. Marking and layout tools are the first set of tools that will be used in the construction of any wood project. These tools are used to transfer the design, size and shape from the paper to the wood by means of measuring and marking. These tools will also be used to lay out woodworking joints. There are 5 main types of marking out and layout tools. These are rules and tapes, squares, gauges, marking knives, and compasses. Rules and tapes. Rules and tapes are used for measuring purposes. Some common tools in this category are the box rule, the folding rule, the steel rule, and the steel tape. In the construction of furniture in general, rules and measuring tapes are used to transfer measurements from the drawings to a given project. This ensures that the project is built on the designed size. The rules, also called rulers, may be used for short measurements, while the steel tapes are used for relatively longer measurements. Squares. Squares are usually used for setting out 90 and 45 degree cuts. Tri-square. The tri-square is used for setting out and checking right angles. It consists of a graduated steel blade, which is fixed at 90 degrees to a wooden or plastic stock. When checking 90-degree angles, the stock is held firmly against one edge of the surface of the wood. The tri-square may also be used to check if corners and parts of the project are square. Mitre square. The mitre square is similar to the tri-square. The only difference is that the angle between the stock and the blade is 45 degrees on one side and 135 degrees on the other side. Sliding bevel. This is an adjustable tool which can be set at different angles and therefore can be used for setting out and checking angles. The sliding bevel consists of a steel blade and a wooden or plastic stock locked by a thumb screw. Combination square. This type of square has similar features to a combination of the mitre square and the tri-square, and therefore performs the function of both. The stock, which slides along the blade of the combination square, is often fitted with a small spirit level. Gauges. Gauges are important marking out and laying out tools. These provide the service of marking lines perfectly parallel to a true edge or surface. 2 most common types are marking gauge. A marking gauge consists of a beam, also called stem, a head or stock, and a pin, also called spur. The beam holds the pin, and also the head slides on it. The marking gauge is used for marking a single line on a piece of timber parallel to an edge or surface. Mortise gauge. A mortise gauge is similar to a marking gauge and is used to produce 2 lines parallel to an edge or surface. It has 2 pointed steel pins, one fixed and the other movable. This is so that the pins may be adjusted to the required mortise width. Marking knives. Marking knives consists of a wooden handle and a blade, which is made from steel and has an end that is angled. The marking knife is generally used for marking lines to aid in the cutting and in the use of chisels. Compasses. Compasses are used in woodwork to lay out circular acts. Woodwork compasses sometimes have a pencil point and a steel point, or two steel points, and also act as dividers. Tremels. Tremels are used like large dividers to measure length, to mark distances, and also to scribe arcs and circles. Marking and Section 2. The marking of joints, Part 1. Joints. In woodwork, the knowledge and applications of joints is very important to construct furniture and other wood products. There are many types of joints, but we will be discussing some of the most common joints. We will be using the marking tools to mark the layout of different joints on pieces of wood. Butt joint. Butt joint is one of the simplest joints. In this joint, one end of one piece of wood is glued against the other end of the second piece and nailed or screwed together for further strength. Marking the butt joint. 1. Select two pieces of wood, for example of dimensions 250 mm by 100 mm times 19 mm using metric system of units. Or we say 10 inch by 4 inch by 3/4 inch using imperial system of units. 2. Use tri-square and marking knife to mark the right length on the pieces all around. You have marked the two pieces of wood to get dimensions 200 mm by 100 mm by 90 mm, or 8 inch by 4 inch by 3/4 inch. Miter joint. Miter joint connects two pieces of wood which have been cut at the same angle. For most applications, the joining ends of the pieces of wood are cut at 45 degrees, so to create a 90-degree angle between the joints. Marking the miter joint. 1. Select two pieces of wood of dimensions 250 mm by 50 mm by 19 mm, or we say 10 inch by 2 inch by 3/4 inch. 2. Use a miter square and a marking knife to mark a 45-degree angle line at the end of both pieces of timber. A dado joint. In a dado joint, one piece of wood is inserted in the groove of the other piece of wood. Marking the dado joint. 1. Use a piece of board of dimensions 300 mm by 100 mm by 19 mm, or 12 inch by 4 inch by 3/4 inch. 2. From one end, mark a line at a distance of 140 mm, or 5 5/8 inch, using tri-square and marking knife. From this line, mark a next parallel line, 19 mm or 3/4 inch apart, which is the thickness of the next piece of wood. These two parallel lines are on the face of the wood. 3. Set marking gauge at 6 mm or 1/4 inch and press the stock of the marking gauge firmly against the face of the wood and make a line 6 mm or 1/4 inch below the two parallel lines on the edge of the wood. 4. Join the ends of parallel lines to the new line. Halving joint. For this joint, two pieces of wood are joined together by removing material from each at the point of intersection to create a smooth surface when they overlap. Marking the halving joint. 1. Select two pieces of wood of dimensions 300 millimeter by 75 millimeter by 37 millimeter, or 12 inch by 3 inch by 1.5 inch. 2. Measure 112 millimeter or 4.5 inch from the end of one piece of the wood and mark a line using the tri-square and marking knife. Using the tri-square and marking knife again, draw a next line parallel to the first line at a distance of 75 millimeter or 3 inches. This will ensure that the distance between the two lines is the same as the width of the second piece. A different approach will be to lay one piece of the wood on the other at 4.5 inches away from the end and draw the parallel lines. 3. Set marking gauge at 19 millimeter or 3/4 of an inch and press the stock of the marking gauge firmly against the face of the wood and make a line 19 millimeter or 3/4 of an inch below the two parallel lines on the thickness of the piece, representing half the width of the timber. Join the ends of parallel lines to the new line. 4. Using tri-square and marking knife, mark a line on the surface of the second piece at a distance of about 75 millimeter or 3 inches from the end of the piece. Extend this line to the thickness of the piece on two sides. Set marking gauge at 19 millimeter or 3/4 inch and, starting from thickness line, mark a line on the three sides, each 3 inches long, right around the end of the second piece.
Section 3. Marking of Joints. Part 2. Lock-shouldered joint. To construct this joint with two pieces of wood, a part of the end of the first wood is cut and inserted in the groove near the edge of the second wood. This allows a locking action on the corner. This joint combines the features of dado and butt joint. Marking the lock-shoulder joint. 1. Take two pieces of wood of dimensions 200 millimeters by 100 millimeters by 19 millimeters or 8 inches by 4 inches by 3/4 of an inch. 2. For the piece A, using a marking knife and a tri-square, draw a line on the face of the wood at 10 millimeters or 3/8 of an inch from the end of the piece. Set the marking gauge for 12 millimeters or half an inch and draw a line of length 10 millimeters or 3/8 of an inch from the end of the surface line to the end of the board on the thickness side. Extend the marking gauge line to the three sides, right around, at the end of the wood. Link the surface line to the gauge line. 3. For the piece B, using a marking knife and a tri-square, draw a line on the face of the wood at 19 millimeters or 3/4 of an inch from the end of the piece. Draw a second line parallel to the first line at 6 millimeters or 1/4 of an inch in the direction of the end of the piece. Set the marking gauge for 10 millimeters or 3/8 of an inch and draw a line of length 6 millimeters or 1/4 inch below the parallel line on the thickness side. Repeat on both sides of the thickness. Link the surface lines to the gauge lines. dovetail joint. This joint consists of tails and pins. One of the main features of dovetail joints is strength, as the tails and the pins are interlocked, making it difficult to pull apart. This joint is mostly used in drawer construction. Marking the dovetail joint. Select two pieces of wood of dimensions 300 mm by 75 mm by 19 mm or 12 inches by 3 inches by 3/4 of an inch, one called the tailpiece while the other is the pin piece. Tailpiece. 1. Using a tri-square and a pencil, draw a line 19 mm or 3/4 of an inch from one end of the tailpiece. Extend this line all around on all the four sides. 2. Mark the 2 points on the edge of the tailpiece at a distance of 19 mm or 3/4 of an inch from each top corner. From these points, use a sliding bevel set at a ratio of 1.6 to draw the 2 lines for the tail. Using the same points, extend the lines on the sides using a tri-square. 3. Use the marking knife to scribe the areas to be cut. Pin piece. 1. Using a tri-square and a pencil, draw a line 19 mm or 3/4 of an inch from one end of the pin tail piece. Extend this line all around on all the four sides. 2. Mark the 2 points on the edge of the pin piece at a distance of 19 mm or 3/4 of an inch from each top corner. From these points, use a sliding bevel set at a ratio of 1.6 to draw the 2 lines for the tail. Using the same points, extend the lines on the sides using a tri-square. To be accurate, the traditional approach is to cut the tail piece to check the accuracy of these lines and perform the relevant corrections before the pin piece can be cut. 3. Use the marking knife to scribe the areas to be cut. Section 4. Marking of Joints, Part 3. Mortise and tenon joint. Mortise and tenon joints are very popular, especially in the design of tables, chairs, and other household furniture. It has 2 parts, mortise and tenon. The part tenon fits into the mortise part. Marking the tenon. 1. Select a piece of wood of size 525 mm by 56 mm, 21 inches by 2¼ inches by 3/4 of an inch. 2. Using a ruler and a pencil, mark points at a distance of 31 mm or 1¼ inches from the end of the tenon piece. With the help of a tri-square and a marking knife, draw the line using these points. Extend the line around the piece of the wood. This line is called shoulder line. 3. Set the distance between the fixed spur and the adjustable spur of the mortise gauge at the exact width of the 6 mm or 1/4 inch chisel. Tighten the nut for the adjustable spur. Set the stock at 6 mm or 1/4 inch from the adjustable spur of the mortise gauge. 4. Using the mortise gauge, Mark lines starting from the shoulder line on the top surface to the edge, then from the shoulder line on the bottom surface to the edge, and then join the ends of these lines on the front end of the tenon piece. 5. Set the marking gauge for 1/4 of an inch and starting from the shoulder line on the top right surface, mark lines closing on the other end of the shoulder. Repeat the same process for the bottom end of the tenon piece. 6. Mark the areas to be cut with a pencil. Marking the mortise. 1. Select a piece of wood of dimensions 44 mm by 44 mm by 475 mm or 1 3/4 inches by 1 3/4 inches by 19 inches. 2. Using a ruler and a pencil, starting from the top of the wood, mark points at the distance of 25 mm or 1 inch, 31 mm or 1 1/4 inch, 75 mm or 3 inches, and 81 mm or 3 1/4 inches. Use the tri-square and a pencil. Draw the horizontal lines using these points. These horizontal lines should match with the horizontal lines on the tenon piece. 3. Ensure the distance between the fixed spur and the adjustable spur of the mortise gauge is at the exact width of the 6 mm or 1/4 inch chisel. Set the stock at 12 mm or 1/2 inch from the adjustable spur of the mortise gauge. Remember, this width should relate to the width of the blade of the chisel. 4. With the mortise gauge, pressing the stock on the left side of the mortise piece and starting from the top inner horizontal line, push the gauge along the wood up to the inner horizontal line to mark the mortise. Summary and assessment. Question number 1. State 2 safety rules governing the use of the marking knife. Answer number 1. 2 safety rules governing the use of the marking knife are: 1. Marking knives must never be stored in pockets, and 2. Always mark away from your body when using the marking knife. Question 2. Outline the procedure for using a compass to mark out an arc on a piece of wood. Answer 2. 3 basic steps in marking out an arc with a compass are: 1. Locate the center of the required arc or circle. 2. Set the compass to the required arc or circle. 3. Place the steel point at the center of the circle or arc, and then use the other steel point or the pencil point to scribe the arc or circle. Question 3. Differentiate between the marking gauge and the mortise gauge. Answer 3. A marking gauge has 1 pin for marking a single line along the grain of wood, while the mortise gauge has 2 pins for marking 2 parallel lines along the grain of wood. Question 4. Which 2 wood joints are the most common in the construction of household furniture? Answer 4. Mortise and tenon joint and dovetail joint.
Bandsaw. The bandsaw is one of the most versatile machines in the woodwork shop. It is capable of ripping and cross-cutting, but it is primarily used for cutting curves, circles, and irregular shapes. The blade of the bandsaw is a continuous band of metal with teeth along one edge. It usually rides on two wheels rotating in the same plane. The bandsaw has similar parts as the circular saw, such as table, rip, fence, and miter gauge. Segment 1. Parts of the saw. Table. Like the table saw, the bandsaw has a table that allows the resting of material to permit the various operations. The tabletop is where the operator stands to perform their task. The top has a small hole in the center where the blade runs through. It also has a slot to accommodate a miter gauge to allow for cross-cutting. The bandsaw table can tilt to the right at 45 degrees and 10 degrees to the left. These features make the bandsaw the most flexible machine in the woodwork shop. Fence. The bandsaw fence is similar to the one used on the table saw. It allows the bandsaw to perform ripping operations. It is clamped in place by the desired measurement before ripping. When cutting freehand, the fence is removed. Tension handle. This is usually placed on top of the machine. It has a handle to hold to rotate and cause the top wheel to be lowered or raised, which then decreases or increases the tension of the blade. Blade guides and thrust wheel. This is a device that is connected to the upper half of the saw, but projected downwards so that the blade can pass through to go to the lower half of the machine. The thrust wheel can slide up or down to accommodate different thickness in materials. It is usually set slightly above the workpiece. The start and stop control. This is a switch that is used to turn the machine on and off. The blade. This rotates to cut the material that is being fed to the machine. It is connected to the lower and upper halves of the machine to two wheels like a belt on a pulley system in a car engine. Blades come in various sizes. The wider blades are used for straight cuts, while the thinner ones are used for curve cutting. Previously played. Segment 2. Essential safety precautions. Keep your finger out of the path of the blade at all times. Avoid rushing and hurrying when using the machine, as this can result in errors or injury. Gradually decrease the pressure you're applying when near the end of the stock, as this may slip through and cause your body to thrust onto the blade. Always use a push stick when ripping small or narrow strips. Always keep the wheel covers shut while the bandsaw is in operation. Keep the upper guide adjusted approximately 3 millimeters above the material. Always keep the blade guards in place. Unplug the machine while changing its parts. Always wear your protective clothing when using the machine. Use eyewear and overalls. Avoid neckties and long sleeves. Wear gloves when handling large blades. Wear dust mask or respirator to protect your respiratory system. Segment 3. Adjusting and changing the blade. The following steps demonstrate how to safely change the bandsaw blade. The first step to changing your bandsaw blade is to disconnect the unit from its power source, as you would not want the unit to somehow turn on accidentally while you're changing the blade. Once you've disconnected the power, open up the top and bottom cabinets, revealing the two tires between which the bandsaw blade is tightened. Clean out any excessive sawdust or chips to make the job of changing the blade easier. The next step is to loosen the blade tension. Locate the tension knob on top of the bandsaw, which typically is on a vertical shaft above the bandsaw's top cabinet. Loosen the tension on the blade by turning the knob until the blade is loose. Raise the bandsaw blade guard by turning the knob found at the back of the guard at the back of the top of the cabinet. Slide the guard up to the highest position and tighten the knob to keep it in place. The next step in changing a bandsaw blade is to remove the rear blade guard. Usually, a Phillips screw on the top and bottom of the guard secure the guard to the chassis. Set the guard and screws aside for the time being. Remove the insert in the center from the middle of your saw table with a screwdriver and set this center aside. Then look down into the hole and locate the screw that holds the protective wrap-around guard in place. Loosen the screw that holds the guard in place and then rotate the guard 180 degrees until it is out of the way. With the entire bandsaw blade guards removed or safely out of the way, you may now remove your bandsaw blade. Grab the blade near the top wheel. Pull the blade off of the two tracking tires and rotate it 90 degrees so that the blade's teeth are pointing to your right. Guide the blade through the slot in the saw table until it is clear of the bandsaw completely. Fold the blade and tie together for storage. Slide the new blade through the slot in the saw table in a similar manner to the way that you removed the old blade. Once the blade is through the slot and in the center cutout of the table, rotate the blade and place it over the top and bottom wheel. Center the blade over the center of each of the two tires and begin tightening the tensioning knob on the top of the bandsaw to hold the blade in position. Do not over-tighten, particularly if you're going from a very small blade to a very large one, or vice versa. Loosen the set screw that holds the guide block on either side of the blade on the sliding guard above the table. The blocks should slide freely left or right, either toward or away from the blade. Then loosen the set screw and rotate the rear roller backwards, away from the rear of the blade. Repeat the step for the set of blocks and roller underneath the table. We will now apply the proper amount of tension to the blade. Check to see that the blade is tracking properly in the center of the tires, and then begin tightening the tensioning knob. While tightening the tension adjustment knob, rotate the top bandsaw wheel, all the while watching to see that the blade tracks in the center of the tire on the wheel. If the blade is tracking too far away or to the rear, rotate the tracking adjustment knob in the back of the bandsaw's upper cabinet. Keep adjusting the tracking knob until the blade rides perfectly centered on the tire. Keep in mind that a minor adjustment to the tracking knob can mean a big difference in how the blade tracks on the tire, so make small adjustments to the tracking knob until the blade is centered. Look on the back of the saw's upper cabinet for a tensioning gauge. Adjust the tension on the blade until the gauge's indicator is positioned for the proper blade thickness. A wider blade will require more tension than a thinner blade, but the indicator should have appropriate marks for most blade size. Once the blade is properly tensioned and tracking in the center of the tires, it is a good time to be sure that the bandsaw table is square to the blade. Place a square on the table and align the blade of the square with the side of the bandsaw blade. If the blade isn't perfectly square to the table, loosen the table adjustment knobs underneath the table and adjust the angle of the table until it is square to the blade. Tighten the knobs to secure the table in position. When the blade is properly tensioned and tracking on the center of the tires, the next step is to reposition the guide blocks and rollers. Begin by rotating the under table blade guard back into place and tightening the screw that secures the guard. Next, adjust the lower blocks so that they are just slightly touching each side of the blade. Tighten the set screws to hold the blocks in place. Then adjust the forward position of the blocks so that the blocks are riding just behind the teeth on the flat part of the blade. You may need to readjust the position of either block after this adjustment. Next, adjust the position of the rear roller so that it is riding just behind the blade. Tighten all of the set screws to lock the guides in place. Then rotate the wheel and watch how the bandsaw blade tracks through the blocks and rollers. If the blocks and rollers guide but do not touch the table, you've positioned them correctly. Reinstall the spacer in the hole in the center of the table before moving on to the top guide blocks. Lower the blade guard about halfway toward the table and repeat the block and roller adjustment steps that you used for the guides under the table. The final step to installing the bandsaw blade is to plug the saw in and turn it on. Watch the tracking of the blade across the tires and listen for binding on the guide blocks. If you see or hear any evidence of improper positioning of the guide blocks or rollers, or if the blade isn't tracking in the middle of the tire, turn off the saw, unplug it from the power, and make the appropriate adjustments. If satisfied with the adjustments, close the top and bottom cabinets and lower the blade guide to the appropriate height. Segment 4. Demonstration of applications. The following steps demonstrate the use of the bandsaw. Curve cutting. Identify the piece of stock. Mark out the line you wish to cut. The line should be clearly marked. Remove the fence and miter gauge and all obstacles from the saw table. Start machine and allow it to be in full speed. Stand firmly with one leg slightly in front of the other. Put on your eye protection. Adjust the guide about 3 millimeters above the stock. Slowly feed the stock to the machine without forcing the wood against the blade. cut slightly away from the line of the waist to allow for further work to be done, such as shaving and smoothing. Keep your hands at least 4 inches away from the blade. Trying to cut too tight a curve will cause the blade to bind. If that happens, do not stop cutting. Make the cut more gentle by running out through the waist. Once you have cut through, begin again. If the curve is concave, you may have to make a number of straight cuts through the waist wood to the edge of the line before starting the curve cut. As you cut the curve, the waist wood will fall away in sections, reducing the possibility of binding. When working with woodworking machinery, do everything you can to avoid distractions. If someone tries to interrupt you while making a cut, do not avert your eyes from the tool. Finish the cut or safely turn off the saw before diverting your attention. Too often, injuries occur because the operator was distracted. Fixing tools and finishes. Section 1. At the end of this section, you should be able to discuss some fixing tools. No toolbox is complete without fixing tools for essential assembly work in Woods technology. There are different types of tools to suit different needs. Even though these are common and familiar tools, they should be selected and used according to the requirements of a given job. Fixing tools cover a wide range, but most of these tools have either a driving or a turning action. The different types of fixing tools that we will focus on are 1. Hammer, 2. Mallet, 3. Screwdrivers, 4. Clamps and G's. Now let us look at hammers. A hammer is a simple tool designed to manually drive nails, brads, and other fasteners into softer materials, such as wood or drywall. A hammer has a head and a handle or shaft. Hammer sizes are defined by the weight of the head measured in ounces and pounds, even in these days of metrication. Depending on the type of hammer, the weight of the head usually ranges from 4 ounces to 20 pounds. The common type of hammers are 1. Claw hammer, 2. Ball peen hammers, 3. Pin hammers, and 4. Sledgehammers. Claw hammer. Construction and household hammers are usually claw hammers, usually heads weighing 7, 10, 13, 16, or 20 ounces. This hammer usually has a curved claw, which is used to extract nails. A good quality traditional claw hammer has a handle made of hickory, selected for its great shock-resistant properties. The head should be fixed firmly to the shaft or handle with hardwood and iron wedges, and well balanced for driving nails straight in the wood. The discussion of hammers is not complete without discussing different types of nails. Nails. Let us look at the types and uses of nails. One of the application of nails is to attach two pieces of lumber, usually driven by a hammer or power tool. There are several types of nails. The main types include common nails, box nails, finish nails, casing nails, duplex nails, cut nails, and roofing nails. The size of the nail is defined in terms of its length in inches. In the old days, these were defined in terms of pennies or D. For example, if a carpenter could buy 103-inch length nails for 10 pennies, then these nails were called 10-penny or 10D nails. Selection of nails. Selection of a type of nail depends upon application. Selecting the length of a nail depends upon practical consideration that the length of a nail is usually 3 times longer than the thickness of the material to be fastened, but less than the total thickness of the two pieces to be fastened. Safe use of a claw hammer. Step 1. To safely use a claw hammer, select the weight appropriate to the fastener to be struck and ensure that you are wearing the necessary safety glasses. A. 7, 10 or 13-ounce hammer is adequate for tacks, brads, and small finish nails. 16 and 20-ounce hammers are used for framing and roofing, usually with 2D to 8D or 1 to 2.5-inch nails. Step 2. Hold the nail between your thumb and forefinger with the nail perpendicular to the surface being nailed. Hold the hammer near the end of the handle and watch the hammer head to make sure that it strikes the nail head squarely. Start it with a few gentle taps on the hammer head. Give it a couple of quick taps and pull your hand away. Check that it is again at right angles to the surface. To finish driving that nail, keep your eye on the head and apply more intense strokes with the center of the hammer face. Removing a bent nail. If you bend a nail as you drive it, stop and remove it. Do not try to straighten a bent nail or continue to drive it fully at an angle. Pull it out and replace it with a new nail. Place a piece of card or thin wood on the surface beside the nail. Hook the hammer claw under the nail head and pull the handle towards you to draw out the nail. Keep the handle vertical so you do not widen the opening of the nail hole. Nailing guns. Nailing guns are power tools used to reduce the labor time. Usually pneumatic nailing guns are used to drive nails. Nail punches. These are used to set nails below the surface of the wood. These are available in various sizes to suit the size of the nails. Bradawls. These are used to form holes for nails. It consists of a slender steel stamp with a chisel edge to make the holes for nails and screws. Section 2. At the end of this section, you should be able to discuss the types of hammers. Now we are going to further introduce some common types of hammers. Ball-peen hammer. A ball-peen hammer has two ends, one ball-shaped and the other flat surface. It may have a metal, fiberglass, or wooden handle. A flat face is used for striking. The rounded face is used to align brackets. It can be used with chisels and punches. The heads can weigh from 6 ounce to 2.5 pounds. Pin hammers. These hammers are also referred to as Warrington hammers or cross peen, and are sometimes simply called jointer's hammers. Peen is the name given to the end of the hammerhead opposite the striking face, which are sometimes rounded for special applications. This hammer is ideal for light joinery and cabinet work. Common pin hammers have a head of weight 4 ounces. Sledgehammers. It is a heavy-duty tool to drive posts or large stakes. These can have different size handles. They can be used both in carpentry and in masonry. The head of the sledgehammer is usually made of high-carbon steel, and weight ranges from 2 to 20 pounds and is used for heavy work. Mallets. Rubber mallets. A useful tool for assembly work, and are used when a softer blow may be required to knock a component into its position. The rubber head will not bruise the surface of the wood. They are typically used to assemble parts. Carpenter's mallet. This is also called a wooden mallet, and its head is made from solid beech wood of the correct strength and density to deliver a sound blow to a chisel without jarring. An essential tool for any carpenter, and these are primarily used with chisels. General safety in the use of fixing tools. Tools can be dangerous if incorrectly used or abused. When using tools, ensure you have taken practical precautions to avoid accidents, including the following. 1. Keep tools securely held and ensure that when working with tools, the operator has a good, firm foothold and is well balanced. 2. Ensure the floor is clean. 3. Always use the right tool for the job. Only use tools for the purpose for which they are designed. 4. Develop a habit of using protective eyewear at all times. Screwdrivers. A screwdriver amplifies the hand's turning motion to the small, specially designed tip, which is inserted into the screw's head. There are numerous tip designs for special applications. The types of screwdrivers are identified by the type of screw heads to be used. The two most common consists of standard, also called flat, flared, or straight, and Phillips tips. Screwdrivers play an important part in the day-to-day work of carpenters and joiners. As a number of types are available, it is essential to emphasize the need